Uh, Today we'd like to talk about a sort of groundbreaking technology, P2P networking technology, which is called the P2P communication vehicle. This is the agenda of today. We'll first go over what P2P communication is, and we'll divide the presentation into main two big parts. One is how information is exchanged, and then we'll talk more about how multiple vehicles can communicate at the same time with some sort of examples of how P2P communication can avoid collisions. Then we'll close today's presentation by talking about some future prospects of such technology.
Okay, thanks, Cyrus. So, V2V wireless technology, is so-called vehicle-to-vehicle communication. It's a breakthrough technology that designed for the drivers to communicate, to exchange their information, which means maybe the roadside information or the car situation to each other. And this technology is mainly being operated in a radio wave with a frequency around 5.86 gigahertz. But of course, this is a rough number. That should be a frequency interval for these kinds of radio wave. And the major information being consists in the signal to be transferred and exchanged are the speed, direction, position of the vehicles, and also the time difference of the signal being sent. So here are three major components of the V2V technology. One is the GPS antenna, which is of course need to locate the car to provide the location position checking of the vehicle, and the other is V2V antenna, which is to keep continuously emitting the signals and containing those speed, direction, position information of the vehicles, and also receiving the information from the surroundings. And the last one, which is the most important one, is the data processor. It helps the vehicle to process the data received from the surrounding, like the speed and location, to calculate the acceleration and also the direction of the other vehicle, to predict the pathway of the vehicles, which means that if the pathway being overlapped with the substance, that means there will be a maybe collision will be occurred. So just in case that if you are a driver of the vehicle behind, and there is a vehicle coming ahead, you will receive the signal from the former, and after processing these kinds of signal, then you can the processor will help you to calculate the distance between two vehicles and point out the warning signal to the driver if the distance is too short, which means maybe collision is occurred, or your car is too fast, you may slow down, or everything press the brake. Here is one of the application of these kinds of technology, which is the FCW, forward collision warning. Suppose you are the driver of car B, and you're moving at a speed V. So the distance being calculated by the data processor is like the equation, just as the speed of radio wave times the time difference of signal received and transmit. But of course, we have to consider the speed of vehicle. But compared with the speed of radio wave, that is not significant. So we can find out the distance between the relative distance between the two vehicles, and hence, so if the speed, which means the relative speed of 3 seconds, the distance is greater than that kind of distance that we calculate through this formula. The driver will be provided an FCW, which means the collision may be occur in less than 3 seconds, because it is a general specification for a driver to be at, to press the brake or to slow down the speed. So here is here is the illustration of FCW.
The forward collision warning application, or FCW, is intended to warn the driver of a potential rear-end front with a stopped or slower-moving vehicle ahead. You are driving over a small view, and ahead in your lane is a slower-moving vehicle. The vehicle ahead is wirelessly provide a warning if you are approaching too quickly and or in a potential rear-end crash situation. This will enable you to slow to a safe speed and distance behind the slower-moving vehicle.
Now, consider that a vehicle ahead of you has, for example, run out of gas and is stopped in your lane. The vehicle directly in front of you makes a late lane change around the stopped vehicle. Even though you can't see the stopped vehicle, because of V2V communication, your vehicle is aware of the stopped vehicle and provides you with a warning ahead of time so that you can safely slow your vehicle before reaching the stopped vehicle ahead.
So we just learned how vehicles can situation. Now let me walk you through how multiple vehicles can achieve the same result at the same time. So a very fundamental concept that we have to first learn here is the wireless technology used in communication. As you can see here, among the three existing and popular wireless technologies, DSRC, or long-form dedicated short-range communications, is used for three main reasons. First, the greatest coverage. Second, highest mobility. And third, lowest latency. Latency here is the concept of time delay between message transmission and reception. In other words, low latency or lowest latency means that DSRC has the highest efficiency in terms of message delivery among the three wireless technologies. Like I said before, DSRC, just like some other existing wireless technologies, so it has several frequency channels for communication purposes, and the frequency channels are of frequency ranging from about 5.86 GHz up to about 5.93 GHz. In particular, for V2V communication, about in the very left-hand side frequency channel 5.855 and 5.865 GHz frequency slot is reserved. So in the previous example, forward collision warning, the warning message is transmitted and received through this particular reserved slot. Next, there are two more concepts we have to keep in mind in order to have a more comprehensive understanding of this multiple access scenario. So the first one is about infrastructure that we need to achieve this multiple access. That's in RSU, or what we call roadside unit long form. These infrastructure functions similarly to what we call a space station, and this unit is built literally on the side of the road just to coordinate transmission and reception of messages, as well as extending network coverage. Then, the last piece of concept here to pick out is the multiple access method. Now, this is a very brand new concept to us because we haven't learned it in class. It is called the carrier sense multiple access with collision avoidance. Some may regard this multiple access method as similar to FDMA for in class, right? This is because these multiple access methods also rely on a particular frequency channel to transmit and receive message. But the major difference of this multiple access method from FDMA is that a node in this multiple access method will first listen and ensure that there is available frequency slot before transmitting any message. This is an illustration of how RSU and CSMACA coordinate in the DSRC wireless technology in order to make the multiple access happen. So suppose that we start at the very left-hand side here. The vehicle will see that there is possible collision in a few seconds. So it would like to slow down the speed and also signal this reduction in speed to the vehicles behind it so as to avoid further possible collisions. So what it would do first is to check with the RSU nearby to see if there is any available frequency slot for it to transmit the message. If there is, then the message will be transmitted to the RSU, and the RSU will relay the message to the vehicles behind, very left. inside the vehicle. So this is pretty much how the whole network works here, how multiple vehicles can communicate at the same time. So in previous animation, you might have already recognized some sort of major drawback of CSMACA, which is a low efficiency of message delivery because of the compulsory procedure of checking with the RSU. And some researchers have found out that the worst case scenario is that message delivery might fail, 8 times out of 10. In light of this, some engineers have investigated into other multiple access methods. One of the very possible means is the use of STDMA, or what we call self-organized, time-efficient multiple access. This is quite similar to what we've learned in past STDMA, but the difference is that STDMA does not involve any central station for time assignment. So in other words, it would get things done without going through one more channel or one more station, so that the whole process is being sped up and the efficiency is higher. It's quite a hectic presentation, but the key takeaway of B2B communication is that this communication technology can help us avoid possible collisions, and the continuous investigation, research, development could let us really have a more safe traffic in the future. Thank you for staying for us again, and hope that you have enjoyed our presentation. Thank you. Yes, please. Oh, like I said before, okay, so let me give you some hard figure. So as you can see here, the RCA coverage is around 300 to 1,000 meters. So beyond this range, the coverage that rely on the RSU, because the RSU will help you to extend the coverage range, just as what base station